Yeah. This one. So it's like an expression, no? So you are able to justify it for a given condition. For more help or detail, you can go through that. So that is the point. It's very crucial. In fact, I would advise you that take this portion as a part of your assignment problem. So whatever practices, take it as an assignment problem, so automatically it will become question. So that is something we discussed. That is the end condition. It's very critical. Now that is the generalization. Generalization when we are considering some distribution function. So I am skipping it. Markov model. Right now skip this portion. We will take it as a model 3. No, not one. Post medicine for the report. This we will discuss. Okay. Extra you can leave. Okay, if you have interest, go through it all. Some contents, some of the slides you can skip, maybe repetitive because it has been collected from 2-3 books. So somewhere you might get redundancy. So that is very important point aspects. So we have discussed it. Generalization model, stupid, that we have been already discussed. Okay, concept of redundancy. Okay, so like very only 3 lines, but very vital slide. Many a times I have told you like that in industry we use 2 different approaches. Okay, one simply we called active and redundant, active and standby mode. Okay, another we called active, standby and not. So what is the difference? So it depends on again the criticality of the condition. Okay, say for example system is so critical that you are mapping or you are controlling and monitoring each and every actions on a fully automated mode. Okay, so when you say fully automated mode, that means without any human intervention, okay, or waiting for any instruction from the HMI side, human machine interface side, your machine should be authorized and is able to take certain decisions and execute it there. Is that all? What is your power? So on those scenarios we use it hot mode, like previously I have shown you that case study. So that is in hot mode. What do you mean by hot mode? That means the standby module is fully ready. Okay, it is fully ready. At the same time, let's say module number 1 and 2. So on yesterday case we had taken T83B and T83C. For example, T83B reservoir is an active. So that means all this feeding action is right now pursuing through 83B. Okay? On the other hand, the bottom one 83C okay, was in standby mode. Now, if you are pursuing the real-time scenario where you could not even want to wait for some microns of seconds difference. Okay? So on those scenarios, what should be done? The standby module should be fully ready. Number 2, there will be a clock synchronization among 83B, 83C and the control. Okay. So it will come with a feature that if let's say the feeding process is timely over by the 83B, either it is fully consumed, that is one scenario. Number 2, 83B line is facing some problem, let's say. Okay. So either it requires some maintenance issue or it is normally operating. Now whatever the capacity of 83B was, it has been already fitted. So if it is fitted, then it has to come through the next stage, that is depressurization. No more inactive operation, so it should go in standby, and the standby one should swap its position on active. Getting my point? So this transaction should be done in real time. Getting my point? So what do you mean by again real time? Because your processor, or I would say your controller, has already dictated that I need each and every report or data, or I would say more specifically sample, within the frame of 5 microseconds. Otherwise, I'll consider it as a delay. Okay? So your duration of operation should be executed less than 5 microseconds. Because you have programmed the entire system in such a way that it has been executed around in 2 microseconds. So you have another 150% reserve capacity. That means if needed, you can repeat one more cycle within the sample itself. Okay? So in 2 microseconds, the last sample has been collected from 83B. That is the last point when 83B is feeded. Now it's empty, so it has to switch to standby mode. The standby one should take over in active mode. So this transaction will also take some time. Now 2 microseconds plus this swapping time, so that the 83C come into the power or in active mode. Okay? So everything should be done again within 5 microseconds. Correct? Now because your sampling time was actually 2 microseconds, guideline is 5, but each time you are able to complete your work within 2 microseconds. So now 83C can take another 2 microseconds of time and send its first sample that I have started my job. Correct? So this first sample of 83C plus this swapping interaction, that is called complex restart. Now everything should be executed again within 5 microseconds. Okay? If arrangement is done in that way, then we call it hot mode. Clear? So it is as good as that, like the last, with respect to last sample n-1, it was feeded by 83B. That time 83B was in active mode. Now at nth sample n-1, 83B, nth onwards 83C. Getting my point? So your automation working behind doesn't experience any delay because it is well within the guideline. So that is for the understand. Now, if your system is designed in a way that you need a real-time information, but application is not that critical, that where if I will experience certain microns or millisecond delay, it is not going to hamper the performance of your system. So to say. Okay? So in those scenarios, I can take little cost-effective version. I would say that one is warm or active is actually the same thing. Okay? So another is one is in active mode, another one, the parallel one or the standby one, that is rather than hot, it will be in the lightly loaded or typically term we call it warm. Okay? Ready, but it will take over some time. Obviously in that time, initially you will get some delay and application is not getting affected due to this delay. Get my point? So that is your warm, stage 2. Okay? Third is called your standby. Now there are two approaches. Either we use active and standby, or we use active, warm and standby. Okay? So ultimately these are the two benchmark values. Okay? Standby. Sometimes we also call it cold redundancy or unloaded. Unloaded का मतलब क्या होगा? Now, okay, earlier job was done by this bench. Now you have given me instruction, so I will start working. But of course, during this exchange of information, it will take some time. Okay? It may be few minutes also. If your application is not hampering with this performance issue or this compromise, go ahead because that is the most cost-effective among the three. Understand? But the mathematics working behind it, whenever you talk about redundancy, will remain the same. Clear? Is it clear? So from reliability aspect, you do not experience any difference. If you judge it from automation aspect, then there is a difference. Clear? Then okay, these things FTA right now, okay, we are doing. Today we will discuss. Just all component is over. That is something we have already discussed. This one, system reliability analysis based on certain parameters. Okay, redundancy. So that is the system reliability we discuss. Any doubt over here? That is very critical aspect. Okay, think over it. Remember that not necessary that this is the arrangement. That is basically the Ph.D. diagram of that model, and I would say that this one is the equivalent system reliability model. Okay, to be make it even more specific, we can add more and more components. Okay, as a critical stage. So you can say that these are my critical stage as far as that entire P&I diagram is concerned. How many? 1, 2, 3, 4, 8 plus 12. So I would say that there are 12 more critical components. Some exchangers are connected to pressurization mode, some exchangers are connected to depressurization mode, some exchangers are connected to on-off mode, that is the inlet and outlet wire. Okay, these are the reservoirs, the processing unit I would say. These are the reservoir, these are the parallel line of bypass line. Okay, so based on this analogy, we develop this conclusion that this is how will ensure the maximum availability of that particular system. Okay, if numeric value is given, you are assuming some numeric value, you can do those calculations, you can find some numerical values. Like I have shown you a table where it has been proven that its reliability is more than 90%. Okay, so the nearest one was at that time around close to 80%. So there is a huge deviation of improvement of roughly around 11%, more than 10%. Okay, so that was the reason why it has been predicted. So that is reverse analysis. Now let us go through the faulty analysis of FTA. Okay, now FTA, the structure, the representation, what you see, that is called fault tree diagram. Okay, now what is it? So fault tree diagram says that because initially we have been concluded that the rate of failure or hazard rate is 1 minus the reliability rate. Okay, if reliability rate is 90%, the upper value, that means the maximum chances of failure during the operation stage, during the useful life period, or during the CFR, considering the CFR rate is 10%. So its rate of failure is less than 10%. So it will vary from 0 to 10% at any given point of time. If the maximum reliability is compromising, proportionally your failure rate is increasing, or that means the chances of failure is increasing. Whose chances of failure is increasing? Component chances of failure is increasing. Okay, there are many components participating together to form a system. So one of the component performance may again affect the entire system performance. Yeah. So that's why that has been very, very important. So this is what we call the overall conclusion. Now let's see. So again I am repeating, these are the structures. Let's say we have been divided in 3 portions yesterday, that is stage 1, stage 2, stage 3. Now let's see. Okay. Over here. That is the fault tree diagram of that particular model. Okay. So what it says that the whole system will fail. How? Say for example, take this. So from here we got a row. Okay? We have been observed that this one is basically itself a matrix. Okay? Which ensures the double check the availability of the resources to do the needful job to the next section. But if it is facing certain problems, okay, then the parallel line can be used. If you want to use it at full capacity, so both the lines can be used, which is actually 1 cross 8 matrix 2 plus 1 cross 8. Then if this entire reservoir, that means the inlet stage or outlet stage is facing some problem. So for those stages, unless to avoid the interruption into the operation, we have come across this super insulated vacuum line. So for time being, it has the capacity to bypass it. Okay, highly insulated line, so it has actually maximum pressure bearing capability. Okay? Then it reaches to this point. So these are basically not only a reservoir, but especially reservoir, I would say. So we call it now tank. We have abbreviated something else. So these tanks are basically prepared to process that compressed gas in this case. Okay? So obviously when it has been processing compressed gas, so it also has to follow certain guidelines of that chemical engineering. Okay? They are thermodynamics or whatever fluid dynamics, whatever the rule is, we have to follow that. So they have given certain guidelines. Based on that, your instrumentation is made. Now, if this line is facing some problem, this one can entertain or vice versa. Okay? So problem again starts in this stage. If let's say super insulated vacuum line's outlet stage and the reservoir both are facing a problem at the same time, then it can choke your uninterrupted supply. That is number one. But might be possible that the moment when you are getting a problem, let's say here at common junction, understand? Before that, probably that B and C both are completely filled. Let us assume a base case scenario. It's stage 2. Okay? If both are filled, let's say that each stage is designed to entertain for 2 hours. So that means at least for around 4 hours, my job can go on even the stage 1 is facing some problem. Done? Facing some problem means it is not in position to entertain you on a given time. Okay? So then, if that is so, within that 4 hours, again this system can choke if there is a problem at common junction here. Okay? Common junction in terms of schematic diagram you see, if you see the basically clear die, it's actually parallel. 2 parallel lines. Okay? So that means the problem at outlet valve of both the times should come at the same time, which is very rare. Why? Because one will be only instant. Okay? So if its feeding capacity in terms of hour is 2 hours, so guideline is that roughly it should be ready by 10 to 20% of the time. Understand? So 2 hours is roughly 120 minutes. So 10% if it is looks very cozy, so then go for 20%. So 20% is roughly around 20-25 minutes. So within 20-25 minutes is a depressurization, filling, pressurization should be okay. But yes, that 20 minutes is again crucial. Right? By the time this one is not ready, and here are getting some problem. May happen. Okay? So then this system will choke. If both are facing some problem during the common zone, common time zone. Then again here, okay? Then again here, the difference here is that these are the on-off actions, these are the continuous regulations. Okay? So that's why we keep it separate. Okay? Nature is different. Understand? One is the inner circle, one is the outer circle. Okay? Now, should not be any confusion. A is all related to this, and these B's are all related to this. Okay? Now check this. So here I mentioned that your HCS stands for the hydrogen handling system, fails. So that means the whole system fails. Fail होने से क्या होगा? It is not going to feed hydrogen to the stator casing line of that generating section. है ना? Huge size of conductors, ठीक है? Will generate, and the current amplitude is 30 ampere, 40 ampere, 50 ampere, 60 amperes, huge. What will be the power dissipation? I square R. Imagine that the kind of heat it is dissipating. Okay? So you need to dissipate those things from the stator and rotor sections. Now rotor section is itself dynamic, you cannot do anything. At least in stator section you can keep those arrangements, and you might have seen that there is actually water pipeline. So we flow the chilled water inside the pipe. So I would say that pipe is itself like a vessel. It's not like that there will be a leakage, no chance of leakage. If happened, then God knows. Okay? So water is flowing. Now chilled water is. Chilled water means below 0 degree तो नहीं होगा ना? होगी? नहीं होगा, है ना? Otherwise it will form a ice. Then again you have to invest some heat to भैया थोड़ा गर्म हो गया, है ना. सो वेरी पुअर डिजाइन दैट यू आर यूजिंग पावर टू जनरेट द पावर. ठीक है, यू आर यूजिंग some fuel to generate power, understood, but you are using power to generate power, that's not good idea. So chilled water, that means is roughly very cool, roughly around, let's say maximum is around 70, okay? 5 to 7 degrees Celsius. What is your external temperature? Definitely more than 20-25 in the worst case, maybe in summer time even more. So difference कितना हो गया? Around 20 to 40. So sudden 20 to 40 degree difference good enough to transfer your heat or extract your heat. That's the philosophy. So now water is getting heated. ठीक है, water तो recycle कर दोगे. Like this power channel is like all, I mean very robust design. Don't require any huge maintenance. Hardly you might have seen that the power channel is stopped and they are doing some maintenance through the canal. Hardly you might have seen, है ना? Very rare. But it's like an open bed, है ना? Heat water को क्या किया उन्होंने? Just dump in our open reserve. ठंडा हो जाएगा. Then later on it will march through the again the same route, mainstream line. That is not. Everywhere may not have that much amount of space. In fact, that is a very old design. Today, if you think of to implement something around in this area, not possible at all. Okay? So then you have a closed loop actions. ठीक है? Recycle कर दो उसको. Because again recycling will also remember. The poor thing here is that actually you are dissipating. तुमने hot water को छोड़ दिया, ठीक है ना? Because from that perspective it has of no use. But you could have been extract that heat and recycle it. If you could have been done, then your power plant efficiency could be gone. Okay? So your power plant efficiency here, I doubt that it could be hardly 30 or 40%, but even not 30%, roughly around 30-35%. ठीक है? I am talking about thermal efficiency, not electrical efficiency. ठीक है? So those guys they can do this, but ultimate thing is that this coolant is now what heated. अभी उसको तुमको क्या करना है? Chill करना है. So the next line is the hydrogen. Getting my point? ठीक है? Now hydrogen is a much cooler substance because it's already in compressed form. So it will extract the heat from that hot water line very fast. Understand? Now it will come back. Understand the critical use. And here I am talking about that when your every generating section's capacity is roughly around more than 200 megawatt. Every section. And you know that there is a multiple sections, right? We don't use one section. If I want something a plant size of 1000 megawatt, so having a capacity of 1000 megawatt one unit is a very bad idea. So roughly we go for 250 megawatt 4 units or 330 megawatt 3 units, something like that. Again the same issues. Okay? So now in every stage we are going to use this. So my if HCS fail, so remember it will straight away impact your generating section. Okay? Within few minutes of time, not in seconds. It's a little sluggish process, but not that sluggish. Within 10 to 12 minutes of time, that will be like a buffer zone. You have to decide that probably we are just cut off, stop generating. ठीक है? And indicate to your grid, or your grid go or power grid or somewhere that I am unable to do. Okay? So that is the criticality of this issue. Remember, right? So this whole we said that this whole section fails. Now when it will fail? When each and every probability of to ensure the uninterrupted supply of this pressurized hydrogen fails at the same time. Now what are those probabilities? Number. So that's why remember this one is your OR gate. Because everything has to fail at the same time. 0 plus 0 plus 0 plus 0. There should not be single one. Right? Now therefore it is OR. Now this 4 bar indicates that actually you have to feed it at 4 bar pressure. Okay? I have nothing to do with that what you are doing inside. You constantly supply at 4 bar. Okay? Immaterial from wherever you are. Okay. Now my whole P&I is taking care that number one probability could be power supply. Power supply possible, huh? So I need to take care of that. That the industry has to contract with its transmission utility, है ना? जो करना है कर लेना, होल स्टेट को बंद करना है कर देना, okay? But you have to supply the power at this voltage level constantly and uninterruptedly. Plus, I'll call back. Huh? Okay, understand? So this is the reason that why these power utilities sell at a higher benefit. Remember. Now there is no role of end user. They are not, I mean, like an individual human or resident or agriculture people or something, where you have to some token of subsidy to make them feel happy. नहीं 5 साल में प्रसाद मिलेगा ऑन रिकॉर्डिंग नहीं 24 में आ रहा है सेलिब्रेशन, ठीक है? इंडस्ट्री है, इंडस्ट्री क्या मिलेगा? डोनेशन मिलेगा, but industry actually they are meant for, on a serious note, industry is there for commercialization. It is there for to make for profit, na? It's not a not for profit organization. Okay, you may treat yourself as a not for profit organization because you have a connections with the generations and you have a certain rules. Okay, so you can say that these higher education sectors or this public institute is run based on not for profit philosophy. ठीक है, ऐसा नहीं होता कि प्रॉफिट नहीं होता है, बट एट द एंड ऑफ द डे इट कम्स विद द पब्लिक मनी, वट एवर रेवेन्यू वी आर जनरेटिंग दैट इज ऑल्सो पब्लिक मनी, मेजर फैक्टर, ठीक है? सो इवन इफ सम प्रॉफिट इज देयर इट इज स्टिल पब्लिक मनी, इवन सम लॉसेस इज देयर और लेट्स से सम न्यू प्रोजेक्ट हैज कम अप लाइक एनहांसिंग द कैपेसिटी, सो वंस अपॉन अ टाइम in a decades we utilize some public money to create the initial infrastructure. Getting my point? Okay. But unlike that, those industries are not like that. So they can buy at the higher tariff because उन्होंने promise क्या लिया है? मेरे को supply करता है ना? Okay? Now supplier भी बोलेगा, सर थोड़ा सा ज़्यादा पैसा लगेगा, ठीक है ना? है? इनको हम 5 रुपीस में देते हैं, है ना? बहुत चिक चिक करते हैं, आप 6 रुपीस दे दो, जरूरत पड़ेगा तो उसका पावर कट करके आपको दे देंगे, दे दे, okay? Because we consume at some kilowatt capacity, so we cannot do negotiate. But for a moment, that says that if you can negotiate with TPWDL, है ना? 1.5 रुपीस ज़्यादा दूंगा, don't cut. They will say that नहीं कटेगा, कटेगा only that हम खुद कट गया. ठीक है, okay? So that is one issue, but that is not our engineering, but that is a scenario. So I have to ensure that this should not fail. Remember that because it is an industry, so I cannot run my entire show on a DG because you are a low power consumer. So you can think of to run your show for a time being on a DG. DG पे अगर हम इंडस्ट्री चलाने बैठे तो हो गया, the product cost will be so high that nobody will buy. ठीक है? The only solution is the utility power. Actually, it looks costlier for us relatively to residential cost, but otherwise, from industry perspective, if you see, they got the cheapest. Okay? As compared to their other alternatives. And if the plant size is so big that they can have some captive power plant, so that will like an additional interest bonus for them. Obviously that will reduce substantial burden on as compared to dependency on the utility. Okay, but like that is the one thing. Now rest you see, other than this you see, what is this? Reservoir and SIPL. Okay, so here I mentioned that reservoir and SIPL both belong at the same time. Okay, and its output pressure is how much? 32 bar. So relatively you see for comparison, you check that if you move from left to right, it is decreasing. Understand? Why? Because this one is the final stage. Okay? So that is both are fails. Now why it will fail? Because what is the input to this? So that affects. So affects you remember? Yes. So these two are in parallel. Yes. So complementary of this is there should be AND function. There is a AND logic, and if both reservoir and SIBL fails during the common time. During the common time period. ठीक है? Here you see AND function. Okay, so reliability was signature by R of x. So now same symbolic representation I am taking f of x. ठीक है? So f stands for your filling. Now input to this reservoir is 161. Much high pressure. ठीक है? It can also be here, it can also be here. So that is mentioned. The input pressure is very high as compared to its output pressure. Okay? Will it come back? ठीक है? Even you have NRB, don't have NRB, still it will not come back because the factor is roughly around 5 times. Okay? Now, but if reservoir as well as SIBL both fails at the same time, so this ending is representing this. If both fails at the same time, then and only this block this stage will block itself. ठीक है? हाँ? So there, right? ठीक है? नहीं?
So why you are using and get to represent that both will fail, then you are in end one will fail, then automatically the system will fail.
So he says that how will you represent it? Like the original design is this one, right? Where this bypass line, in a normal language I will say that in a bypass line is in parallel to a reservoir. He says that what if this entire stage choke? When it will choke or block? If outlet valve of this and this SIBL both fails at the same time. Right now, if one of matrix is failing, it will not have any impact because it is this reservoir is itself a matrix. So if one of tank fails here, not an issue, but that will not suddenly impact my feeding process. Reservoir is completely. Okay? Now, this stage fail and this stage fail both at the same time. See, both are failing at the same time. You will get zero output when? In case of OR gate or AND gate. In OR gate, what is the scenario? 0 0 0, 1 0 1, 0 1 1. But in AND gate, anyone fails, you are failing. Right now. So here what you are saying? If both fails at the same time. Understand? So that's why he says that FTA is the reverse, or you can say that each stage, each component is the complementary of reliability. So therefore each combination is the complementary of the, or I would say that dual of the reliability stage. In reliability both were in parallel. So in fault tree diagram both should be in ending combination. There was a ORing combination, now it should be ending combination. Now this ending combination is responding you only if both are okay. Understand? Then there is no problem. We say that this stage is blocked. We say that this stage is blocked. When it will block? Understand? So now if I am facing any combination of this, understand? So that's why it is actually a AND gate, or represented using the AND symbol. AND gate symbol. Okay? So it says that if this and this both fails at the same time, so in that scenario the whole stage is blocked. Okay? Now obviously this stage is in parallel to this as far as the fault tree diagram is concerned. There it was in series. So now it will be in parallel. Dual of this. So dual of the connection. If you remember that circuit theory, when we do just a small exercise, if RLC is connected, we prepare a dual circuit diagram. Right now. So R's complementary is 1 by R. C and L was replaced by each other values. If RLC is in series, so we connected now and parallel. There you are dealing at the element or component level. Now you are dealing at the stage level but it always start from your basic components. Getting my point? They are both were in parallel, na? Both were in parallel, na? So you see, but this whole stage fail. कब fail होगा? If this whole stage fails together, so together means ending. That is not ORing combination. No? ORing combination gives me option that either I can choose this or I can choose this. But ending combination make it compulsory. That both should be aligned at the same time. Then only I will respond to you. Otherwise, there is a problem. Okay? Now, resolve this part. Processing unit. Little complicated because you have required a lot of stage here. So you should think of that we consider anyone, B or C, one as a active mode, one as a hot mode or standby mode, जो लिखना लिखो, ठीक है? Now input to those lines here, input to those lines were at 64 bar, this is T, ठीक है? 160 bar was sliced down to 64 bar, ठीक है? Now here is 32, here is 64, okay? So and in between we feed one, that is why you feed one NRV. So that means NRV inside pressure, outside pressure will be different. Remember that it will not be same. Okay. So now come back. So I will say that this alpha. Now what was my alpha? Let us check. Here is it. RS and RT both are in parallel. Now what is RS? RY and RTB. So I will understand that it has something related to this. And what about RT? No. Yeah. What about RT? RT is this. RZ and RTC. Okay. So Z is actually your exchanger part. Y is exchanger part. That is your processing plant. That is the processing plant. So it is C. Okay. Now these two are in parallel. Clear? So now we check here. Now I will say that this whole alpha phase, when in this original design, now you see how many critical junctions it has. One, what if the inlet fails? What if the outlet fails? What if the pressurization depressurization module fails? Getting my point? All fails at the same time. So do you think that now this one is in utilization condition? No. Right? Obviously I have to shut down this one. Similarly at the same time, this one will also fail when there are many components. But remember, let's say this PI indicator fail हो गया. What will happen? Will you stop the operation? यही फेल हो गया, इसका मतलब लोकल इंडिकेटर इज फेल. प्रॉब्लम क्या है? नाउ इट इज नॉट डिस्प्लेइंग योर प्रेशर, बट डेटा तो आ रहा है कंट्रोलर को अभी. ठीक है? एज अ ह्यूमन आई में भी अनकंफर्टेबल, बट माय मशीन इज नॉट अनकंफर्टेबल. ठीक है? ट्रांसमीटर स्टिल ट्रांसमिटिंग द डेटा. क्लियर? व्हाट आर द क्रिटिकल कंपोनेंट्स? दैट PV83C2. ठीक है? ये जा रहा है तुम्हारा यहाँ. ठीक? नाउ दिस वन इज द डिप्रेशराइजेशन लाइन. ये भी फेल हो गया. दिस वन इज द फीडिंग लाइन. ये भी फेल हो गया. दिस वन इज द इनलेट लाइन. ये भी फेल हो गया. So then 83C is also नीड. I have to abandon it. Abandon means देखूंगा नहीं, but I cannot take any active service anymore. Now imagine a scenario that all these critical failures are happening through both the line at the same time. What will be the probability? Very less, but there is a probability. I can't say zero. Now let us see that what will be the clear combination. Now better for your understanding, you go from the bottom. I said that He1A and B, ये दोनों पैरेलल में थे ना, ठीक है? Now both will fail. Both will fail. ठीक है? So parallel in reliability combination. So in failure, you will have that series combination. That means end. There is a end logic form करेंगे. ठीक है? So Fy, which is basically a ending of He1A and He1B. ठीक है? क्रॉस वेरीफाई कर लो. If you have any doubt, so now check out over here. He1a and B is C. Where is it? This. Parallel line कौन? So parallel I can say or in combination. है ना? इसका total reliability function कितना था? Because both are in parallel. Let's say it is A and B. So it is 1 minus of within bracket 1 minus A into convolution 1 minus B. ठीक है ना? This one, this formula I have to apply. So इसका dual क्या होगा failure में? And combination. So let me check. Is it and combination or not? है ना? So ये and क्या represent कर रहा है? What if He1a and He1b both fails at the same time? क्योंकि if anyone facing problem, still I can manage my show, na? Okay? Still I can work. My system can work. Can I say that apple fails? No. So that's why you mention here and combination. समझ गए? Every stage you have to do the same thing. So this one fail. अच्छा ये fail हो जाने से क्या हो जाएगा? If it fails, my control balance will fail. ठीक है? अच्छा वो सारे control block थे क्या? No, there was some on off block also. Digital actions. ठीक है? मुझे जो भी mention था तुम्हारा on off block. Inlet valve open कर दो या close कर दो. ठीक है? वहाँ in that application there was no partial loop. Open the inlet valve. So within a fraction of seconds it will open. Close the inlet valve. It will close. Who is dictating? Controller is dictating. Okay? Accordingly your actuator is responding. उसने open बोला open कर दिया, close बोला close कर दिया. ठीक है? So this one is different than this. Understand? So it is maybe an analogous action. It is a digital action. Remember this, huh? So that is I have to keep this separate. ठीक है ना? That's why I mentioned that here is FTB. ठीक है? With respect to that nomenclature, it has been failed. मतलब हमारा on of action or related to type B is failed. ठीक? Similarly like here. Getting my point? Just leave this part. Right? What if all the four UB83, A1, A2, B1, B2, all four are pressurization, depressurization, filling, feeding, all the modes fail due to problem facing by individual units, and all units are facing the problem at the same time. तो इन दोनों का combination क्या होगा? और either this or this, because वहाँ पर क्या था sequential connection था ना वहाँ पर first is the inlet है ना fill कर दिया, before that तुम्हारा depressurization हो गया था, then I got for filling हो गया, आपने pressurization किया, pressurization करने I reached to 16 bar, then I started feeding. जब मैंने feeding start किया तो stage 1 में मैंने उसको depressurize करके 8 बार किया, थोड़ा सा रेट को स्लो कर दिया, प्रेशर मैंने कम कर दिया, that means क्या होगा flow rate you are reducing ना, ठीक है? Then I bring it to 4 bar, again one more step, again थोड़ा स्लो कर दिया, now I made at the desired pressure because my generating section want me to set at 4 bar, not more than that, ठीक है? So now it is ready to feed. So you see that my 83B, which is in right now in empty mode, fails only if all this is together. Very rare combination. If I don't have taken that care, तो फिर क्या होगा? If one of problem I am facing, probably my whole stage would have been facing. Now what is the probability? Probability of failure is there, but it is very rare. Very rare that the 4 different stages, or I would say 4 different modes. What are the modes? Depressurization, filling, feeding, pressurization. Sorry. Depressurization, filling, pressurization, feeding. Back to depressurization. Now all these 4 modes will face some problem malfunction at the same stage. Get my point? Very rare. ठीक है? तुमने प्रिपरेशन अच्छा सा नहीं किया क्वेश्चन में. You have 3 exams to do on a 3 different day. Probability of poor appearance is very rare. Why? Because these are the 3 different topics. Okay? Examining on the 3 different days. Acceptable? Rather than we will prepare a mixed mode paper where the question paper of all the 3 subjects will be there. You have to sit only for 3 hours and go for one test. Or let's say you will sit for 5 hours, go for one test. Now probability of influence is high. Maybe extremely good, maybe relatively much good. Okay? So on the same stage, 4 different ways. Rate of failure, nobody can deny, but very rare. Now, this one is the active mode. Imagine the copycat the same thing with the standby or hot mode. They will also face the same problem. And now both the stage will face same problem at the same time. Okay? Okay? If both things fail, then only this combination will fail. Okay? Otherwise, it has some choice or not. Either it can entertain this line, this one, or this one. Okay? All input right 64 bar. Output is at 16. Okay? Okay, so okay? So this one is 64, this one is 28. Okay? अब तुम्हारा प्रोसेसिंग यूनिट यहाँ पर जहाँ पर तुम कर रहे हो all these actions. Okay? So that's why we keep this thing in this. Why? To avoid the probability of failures. To discourage the chances of failures. Done? Now this part is good. Abhi this one is good, this one is good. What if, because that is the output stage of this unit and these two are in sequence. Yes or no? This stage is in sequence to this or series. What if this one has no problem, this one has no problem, but what if this stage will face some problem? Still it can choke my system. So because these are in sequence, so failure mode में क्या करूँगा? I'll keep both in parallel. If this plus this fail together, right? So check out here. So this one is in parallel to this. Now internal structure is ended. Done? So that is your beta. In place of R beta, now it is M beta. So both are now connected in series. Not series, basically it is called end combination. Okay? Simple. Right? Again, another stage of heat exchanger depressurization will also fail. Can I mix these two together? No. Its job is different, its job is different. Entirely different. This one is meant for depressurizing. This one is meant for pressurizing. Reverse action. So I should not try to do that kind of job at the same place. Better have two different compartments. Your work job nature is very different, your work nature is very different. Better is that take to playground and do your job. So that there should not be any collision in your activities. Okay? So that's why we are keeping this doing that. Understand? Remember this one is related to these control actions. So but we keep it separate. Okay? So this one is and this one is. Getting my point? So now what if other than the power supply, these 4 stages will fail? Also, your transmission utility is unable to entertain you. Done? So remember, this has nothing to do with your C and I engineering. That is, what I need this to run my ship. So that's why we do it as one option. Okay? Now these are the interrelated. Okay? So all these fail. 0, 0, 0, 0, 0. What are you doing? And that is the only circumstances when my system will fail together. It is not in position to entertain anymore. Now you see the mathematical model. You have a new lecture. This one you already have. Share the one. Because last 2 slides I have added. Now you see, for example, what is this FX? Now remember, these all are the failure rate, rate of failure, not the reliability rate. These all are the failure rate. So FX, FTA has an ending combination with FXR, that is equal to FX. Okay? Let's say its value is varying from 0.7 to 0.9. and its value is varying from 0.3 to 0.9. You all already fixed that range, na? Okay? So within that, it will give you a random calculation. आएगा ना? Because let's say it's a very highly reliable component. Its value was given 0.7 to 0.995. क्या range लिया था हमने?
0.9.
Somewhere I mentioned. You have taken 0.9. ठीक है? And I give you one day I will already explain you. So please share your notes. ठीक है? So there was some upper limits. Sorry, minimum limit also. That should not be seen. ठीक है? If you don't know, just assume something. But it should have some understanding. Like this one is very highly reliable component. So its lower threshold should not be much lower than this. Okay? But okay, there are the three different stages. So it's up to you, whatever value you want to take. So you can take that value. Okay? What if this one is 0.9, this one is 0.9? Reliability, na? So that means failure rate here is 0.05 and this one is 0.1 and you are ending both. So you will get some value. Okay? But this value can randomly vary because you do not know when it will fail. Okay? So this may, if let's say its lower value is 0.5. So when it is 0.5, it could be 0.95 or not. Reliability. Confusion? Any doubt? Sir? Say RTA. Let's say it is varying from 0.5 to 0.9 and RSI. It is varying, let's say 0.7 to 0.95. For example, okay? If it is so, then what is F? What is F? That means FTA is varying from 0.1 to 0.5. Okay? It is in this direction, it is in this direction. Okay? And FSI will be varying from 0.05 to 0.3. Okay? Now can you tell me the probability of a value between this limit and between this limit? How many combinations? You get the question. Let's say right now FTA is 0.1, 10%, and FSI is 0.05. That is the best case condition, you say, least chances of failure. But that is also possible, na? That FTA is 0.1, but FSI is 0.3. Do you know? It's the mechanical stress. Na? I can constantly monitor, but can I go and do the maintenance? No, ना? On a real time basis. इंस्ट्रूमेंट यूज भी होता रहेगा, साथ में मेंटेनेंस भी चलता रहेगा उसी इंस्ट्रूमेंट में, नहीं ना? Is it possible that FTA is 0.5 and FSI is 0.05? That is also possible. So within the limit of FTA and FSI, how many combinations will create? N numbers, and that N can be thousands. Depending on the sample size, 10,000s. Okay? तुमने sample size अगर 1 लिया है तो maybe some 100 sample. But if you have taken sample size 0.1, that means variation. Variation is 0.01. Then it will create 1000 probabilities. Okay? And selecting a value within these two boundary conditions is like will bring me infinite combinations. Getting my point? So this is only for when I talk about this one. Same thing you will repeat for Fy. Same thing you will repeat for Hz. Getting my point? Now, what is your Fy? This and this. In reliability model it was in parallel, no? So in faulty model it was in ending rate. Okay? Now, heat exchanger, its maximum capability is 0.8. So that means the maximum chances of failure is 20%. But there is a lower limit also. This one and this, how many combinations will create? another n combinations. ठीक है? Now this n is combination. These n chances of failure has a convolution with these n chances of failure. How many combinations it will create? Mind boggling. ठीक है? Beyond your overhead of calculations. ठीक? You have to apply a digital signal processor at least to calculate these permutation combinations. Now what was f alpha? F alpha कौन सा था? Active mode processing unit along with the one of FS FT. ठीक है? Now I'm just closing these options, so that you see. Where is my f alpha? Yes. This will fail if this and this both will fail together. Now this will fail if these two will fail together. Now this will fail if these two will fail together. So how many checkpoint? 1, 2, 3. 3 checkpoint here, 3 checkpoint here. So 3 plus 3, 6 checkpoints will fail. Not 6 components, 6 checkpoints or 3 stages in parallel. Okay? So this will fail. Now every has some value, some numeric value. Find out that combination. Then finally substitute your fx here, from here, f alpha here, f beta here, here this one f gamma here. Resultantly beta and gamma will nearly same, because both are heat exchangers now. So in this case you will get almost the same. Okay. Even sometimes you can say that it is equal. Okay. Whether equal or not doesn't matter, but these all are combined with all combinations. Now how many combinations it will create? Multiply for, ठीक है? You will get infinite permutation combinations. Okay? Out of which now apply those digital logics. You had a certain don't care conditions. Neglect your. But then there are certain conditions which you cannot get. And probability of happening all those parallel events are together. ठीक है? So if you find those values, then the chances of failure हमारा निकल के आएगा. ठीक है? How do you verify? Let's say कितना मिला था हमको? 90.46. So what was that? RL, है ना? Lower redundancy. LR stands for it was lower redundancy. So if I would say that my RLR is equal to 90.49%. So that means FLR कितना होगा? 1 minus R, ठीक है ना? So it is roughly around less than 9.5. That is the highest probability of failure. ठीक है? Theoretically it may be 0, I do not know. 0 for some sample, not for all the samples. Getting my point? ठीक है? So still there is a definite chances of failure. You have to design your P&I in such a way that you should be able to bypass a stage-wise failures. एक particular heat exchanger में problem चला गया, your show should not be stopped. A particular reservoir was getting some problem, your show should not be stopped. Super insulated vacuum line right now in under maintenance, very rare, but अभी तो maintenance में जाएगा, maybe after 10 years. During the same stage you can face some problem, but still your matrix was designed in such a way that if SIVL, which is a critical line, is now under maintenance, but still your show should not be stopped. ठीक है? Like this. ठीक है? Let's say inlet valve of 83C effect हो गया. Now question is that 83B is ready or not? Remember that superimposed time of 20 minutes we discussed? That is a very critical time. That's why there is a definite chances of failure still exists. Okay? You can reduce it further cost. नहीं, सरकार का पैसा है, लगा दो एक और यूनिट रिडंडेंसी. नहीं, 10% है, 5% है. Okay? But if that one additional unit comes at the cost of let's say 200 crore rupees, हैं? योर MD साहब विल आस्क, हैं? मैडम थोड़ा चैम्बर में आके मिल के जाइए, हैं? What is the criticality behind your decision? I want to understand. To justify na, why you want to another 200 crore you want to spend? What is the benefit? तो 200 crore अगर spend करके within a year, if company can generate 500 crore profit, बिंदास लगेगा, ठीक है? Probably you will win some appreciation award also, bonus also. It fails to justify. Okay, so these are the criticalities you need to understand. Now I am showing you one thing, probably you might have seen in the last day. If you see the criticalities of this F1, F2, F3, how much calculations you need to do? And remember, these all are the parallel calculations. You cannot stop one at the cost of all. ये सारा fx, f alpha, beta, gamma जो भी लिखा है ना, all are being calculated with random values at the same time. Because everybody's reliability is some value. किसी का reliability था 0.72, 0.995. So that means that the reliability is kept on varying with time within the useful life period, and it is constantly changing. Because it's a variable ना, so कभी 0.7 रहेगा, कभी 0.71 रहेगा, कभी 0.95 चला जाएगा, कभी 0.9 पे आ जाएगा, कभी 0.8 रहेगा. I do not know at which sample what is the value. तो कुछ भी हो सकता है. So you will take all the random combinations. क्या वैसा है ना? लैपटॉप पर चलाओगे, it will take around more than 24 hours to give a solution. Mainframe system पर चला दो, but it will still take around 2 hours to give you the final result. Next time you start करोगे, it will again take 2 hours. ठीक है? Because indeed ना, you are an engineer ना, justification मांगेगा तुम्हारा बॉस, डिजाइन इंजीनियर हो भाई, हैं? Attain highest reputation. What is the reason behind it? देखो, I've done a detailed analysis, detailed analysis. Move on. ठीक है? अभी इतना एनालिसिस के साथ जा करके बोलना, ठीक है? 200 करोड़ और लगेगा, आराम से. बस पूछ देना सर, लेट मी एक्सप्लेन. अरे ये सुनी बोलते हैं भैया ले जाए, हैं? हाँ, बैग में. ओके, so that is all about just these standard values. Formulas I have already mentioned. That is just for reference. You can use these formulations to calculate your mean, median, and mode. Mean is nothing but it is your MPTM and MPT. These are the actuals. ठीक है? These are the symbolic representation of median and mode. So anything you see is actually this. What is the formulation you use? You use this. As far as that case study is concerned, your distribution function is changing, this will change. ठीक है? Clear?
सर फॉल्ट ट्री एनालिसिस में फॉल्ट को हम लोग 1 लेंगे और नॉट फॉल्ट को 0 लेंगे. तब
फॉल्ट को
1 लेंगे और नॉट फॉल्ट को 0 लेंगे. तब तो उनमें से एक भी अगर फेल हो रहा है तो अल्टीमेटली 1 आएगा. फॉल्ट में हम लोग 1 लेंगे.
तो ना reliability is 0. That means fault तुम्हारा 100% होगा. So within the unit value it is varying from 0 to 1. ठीक है? तो 1 हो गया. If reliability is at any moment of time it is 1. So उस समय fault 0 होगा. If reliability is 0.9, so fault is become 0.1. Reliability is 0.5 है. Exactly at that point of time symmetric हो जाएगा. Fault में 50% chances रहेगा. ठीक है? So that is over. Still, if you will face any doubt, okay, how to shut down?